Okay, so today's question is semi-ordered permutation. So this has been solved and 1977 cases has been passed and it is and it has taken time is 2 ms and it has taken 43 MB of memory and it is hosted at 100% of the problems. So let me take you the problem solution. So you are given a zero index permutation n of n integers nums. Okay, a permutation is called semi-order if the first number is equal to 1 and the last number is equal to n. Okay, so this is the jumbled word. So this is the array of integer nums where you have to order them into the semi-order permutation. So what does it means that if the number first number is equal to 1, last number equal to n, that is the largest number in the array. You can perform the below operation as many as time until you make the number semi-order permutation. Pick two adjacent elements and then swap them. So you have to always pick two adjacent elements and to swap them. If we pick 1 and 2, after swapping 1 is the first element which we want, but still 4 is left. So swapping 4 with 3, now 4 is the last element, which is the nth element that we can say the largest element. So after two swaps, element is at the and first element is the first place and the largest element fourth place is the fourth place. So this will require two swaps here and one swap here, three swaps, because one will be swapped by 4 and then one will be swapped by 2, two swaps, 4 is here, 4 will be swapped by 3, three swaps. This is already a semi-ordered permutation because 1 is here, 5 is here. So instead you're thinking of swapping the nodes. There's one more trick here. So you know that if the element 1 and element 4 is part away, means the element 1 is less x element, let this be x, we have to calculate this indices and the largest element indices. The smallest element indices is less than the largest element. So the swap is simple. You have to uh, minus this indices with a 0. So one swap will be required here and one swap will be required as a two swaps. Okay, so n minus this indices, the largest element indices. If x is less than y, x is the indices of the small element. Similarly here, if x is greater than the y indices, that is the largest element indices, then the smallest element minus 0 will remain the same and 4 minus the n element minus 1, because one swap is already occurred here. Okay, so the answer will be, first we have to find the after iterating the loop from the nums, you have to find the indices of the minimum element and the indices of the largest element. So if the indices, like this example, if x is less than y, indices of smallest element is less than y, this is simple. The number of swaps required will be math dot absolute 0 minus the x element, that is the smallest element, 0 minus x plus n minus this indices. This swap will be required to make the first element as 1 and the last element as n. If it is not the case, this is the case, the second element, because for one swap of 4 is already taken by the smallest element. So here the swap will be 3 only, but here this is not the two swaps, this is one swap, because one swap is already covered by the 1 and 4. Okay, so what you have to do, you have to follow the same statement minus 1. So minus 1 swap will be required if x is greater than y, means the element which is smaller than the y element, that is the largest element, their indices. So that's why you have to make the minus 1 and return the answer.